Domain and range. Let's start off by defining domain and defining range. So domain is the set of input values of a function or a relation. So input always talks about my x values. So that's what I'm talking about when I talk about domain. I'm talking about my x values. When I'm talking about range, I'm talking about a set of output values of a function or a relation. So that means I'm talking about my y values. So domain are my x values, range is my y values. And sometimes I get those mixed up, but for me to remember it, I think about which of these letters, D or R, comes first in the alphabet. Well, D comes first, and so does X. So domain means X, and range means Y. So let's look at a few examples. On these first three examples, I have lists of numbers. This is a set of points where each number is listed out. This is a mapping where each number is listed out. This is a graph with individual dots, a discrete graph. So these are points listed out. So my domain and range looks a little bit different versus the ones at the bottom. So let's start with this first example. If I'm looking at domain, I'm looking at a set of numbers and I'm looking at my x values. So it would be 2, 8, and -4. And we generally write our domain and range from smallest to largest. So -4, 2, and then 8. Those were my x values, so that means it's the domain. So then range is my y values, which would be these. The 4, the 6, and the 2. So when I write range, again, we want to go from smallest to largest. So 2, 4, and then 6. Let's look at the next one. If I'm looking at the domain, I'm looking at the first circle going to the second circle. So the domain are my x values, the range is my y values. So my domain would be -1, 1, 3, and 5. My range would be 3, 5, and 7. All right, let's look at the last one. I'm looking at domain and range. I remember domain is my x and range is my y. And on a graph, the going horizontal is my x and then going vertical is my y. So when I'm looking for the domain, I'm looking at these numbers down here, the 1 through 10. So, or 0 through 10. So I have a point at 0. I have a point at 1. I have another point at 2. And then 3, 4, 5, and 6. Then my range, I'm looking at my y numbers. My point starts at 10, and then it goes up to 15, and then 20, then 25, 30, 35, and 40. All right, let's look at how that looks different from these down here. And I'm actually going to start with this middle graph. So anytime I have a graph that's not just like a set of points up here, not discrete, I have one that's more continuous, I like to draw a box around my graph. The highest it goes, the lowest it goes, the farthest left it goes, and the farthest right it goes. So it looks like my graph looks like this. It can't go any lower than that. It can't go any far right than this. And it can't go any taller than this. So when I have graphs that are continuous, my domain and range looks a little bit different. I'm not going to be listing it as points. I'm going to have something that looks like this. My domain, which is my x values, would be some number, and then one of these symbols, either this one or this one. So either less than or equal to. X is less than or equal to some other number. Now the way I put the numbers, this is the smallest number. And when I'm looking at domain, that means the farthest left it goes. And this side is my largest number. Or since I'm talking about domain, the farthest right my graph goes. If I'm looking at range, I'm looking at my y values. So I have these same little lines, either this symbol or this one. And I'm looking at the smallest, which with range, since the y-axis goes up and down, I'm looking at how far down it goes. And then the largest, and since I'm talking about range, I'm talking about how high it goes. Okay? So let's look at this middle one again. Some number, x, some number. So I know this one's going to be the smallest or the farthest left my graph goes. So I look at my graph, and the farthest left it goes is right here. And this is at -3. So my graph starts at -3. So then I check what went out to -3. In this case, it was a solid closed dot. So that means I'm going to use this less than or equal to symbol, because my graph could actually be at -3. Now then I look the farthest right it goes, or the largest x value, and I see that it goes out to +3. So this number is going to be +3. And then I look and see which part of my graph went out to 3, and it looks like in this case it was an open circle. An open circle means it can't actually equal +3. So I just use my less than symbol. So now let's do the range. I'm going to leave a blank, y, and then blank. So my range, I'm looking at how far down it goes and then how far up it goes. So if I look down, the farthest down my graph goes is at -3. And I look to see what actually went to -3, and in this case it was a closed dot. So that means less than or equal to. Then I look and see how far high my graph goes, and it looks like my graph can't go any higher than this +2. So I put a 2 right here. Then I look to see what actually went to 2, and in this case it was an open dot. So this becomes a less than symbol without the or equal to part on the bottom. Alright, so let's go back to this one. This one looks a little bit different. This one I had a closed dot, or I had a dot and a graph that went to both of those. This one just has a dot and an arrow. The arrow means that I'm probably going to have something with infinity. My graph is going to go on and on forever and ever. So I know I can stop my graph right here. It doesn't go any farther left than this, and it doesn't go any farther high than this. But I don't know how low it's going to go, because it's going to keep on going and going and going and going and going and going, and I don't know how far right it can go yet. So let's set up our domain, blank, the letter x, and then blank, and then range will be blank, the letter y, and then blank. So with my domain, remember I'm starting at the farthest left it can go. So I know that left-wise it can go all the way out to -3. So I'm going to start with there. And at -3 there was a solid dot, so it would be less than or equal to. So then when I look at my x, I think, well, how far right can it go? Well, this line is going to go forever and ever and ever and ever. So that means I can actually go out to infinity. Now, is infinity some number I can actually touch, like I can actually name? It's not. So this symbol, anytime I use infinity, is always less than, without the line underneath. So let's look at range. Range is the farthest low I can go and the farthest high I can go. So low and high. So if I'm looking at the range, the farthest low I can go, looks like this graph is going to go on and on forever, down, keep on going, never stops. So that means the farthest low it can go is infinity. And since I can't actually touch infinity, it's less than and without the line underneath it. So now let's look at the highest my graph goes. I was able to top off the highest. It's not going to go any higher than this point because my arrow is pointing downward, not going upward. And the highest point was at +3. And in this case, this is a closed dot, so I'm going to say less than or equal to. Alright, let's look at the last one. It says the function f of x is equal to -2x plus 1 is defined for all x such that -3x is less than or equal to x, which is, -3 is less than or equal to x, which is less than or equal to 2. What is the range of this function? Well, I already know the domain. It tells us what x can be. So then we have to look at the range. So that means my x values can be anywhere from -3 to +2. So that means we need to plug in all the numbers from -3 to +2 in this equation. Now I know that f of x means the same thing as y. It's just saying a function of x. So I'm going to say that -2 times -3 plus 1 is equal to the first number in my range, or one of the numbers in my range. And then I would say -2 times -2 plus 1 equals another number. And I'm going to keep on doing this until I get to +2. So -2 times -1 plus 1, -2 times 0 plus 1, -2 times 1 plus 1, and -2 times 2 plus 1. So I plugged in all the numbers between -3 and 2. So I just do this multiplication. -2 times -3 is +6 plus 1 gives me 7. This one would be 5. And then 3, and then 1, and then -1, and then -3. So my range would be -3, -1, 1, 3, 5, and 7.